Jose room giving a presentation. Also, an update for the gala tickets, we are still sold out, but if you would like to be put on a waiting list, we can give you an update after lunch about where we are and if we can give you those gala tickets. And now, I would like to introduce a man who wears multiple hats. He is the former NASA Associate Administrator for NASA's Science Mission Directorate, the current PI for New Horizons. He founded Golden Spike, and he is the current Vice President of the Southwest Research Institute and founder and Chief Scientist for Worldview. And I would like to welcome Mr. Alan Stern.
Okay, hopefully my mic is live. Good morning. Don't think of it as 9 a.m. on the West Coast. Think of it as noon on the East Coast. It's easier that way, believe me. Well, welcome, and I'm glad you could be here for this talk about Worldview. I know for some of you I'm making an introduction of what Worldview is about. For others, it's more of an update. And in addition to giving you a status of what we've been doing and what's coming next, where we're headed, and the markets that we're going to be entertaining, I also want to make a little bit of news this morning. That's coming a little bit later. We have a bit of an announcement to do with our research and education market. But I'll start at the very beginning and just tell you a little bit about Worldview. Worldview is a stratospheric ballooning system for humans, for people, and for payloads. We're going to be pioneering the high stratospheric frontier in a way that's never been done before, making space travel accessible to people who've never been able to think about space travel before, to make it as easy as flying, hopefully, on commercial airliners. We're interested in doing science, doing education, in space tourism, and in other business markets. I'll talk about all that. We think of the stratosphere as a green field, ready for development with the technology of the 21st century. So this is what the flight system looks like for our capsule. It takes off on a balloon, rises to an altitude of 100,000 feet, loiters for hours, and then descends initially on the balloon and then on a parawing to a controlled landing. We think it's going to be a tremendous experience. The cabin itself is large enough for 8 people. It's a crew of 2 and 6 flight participants, whether they're tourists, researchers, educators, or others. This is the only spaceship that I know of that's got a bar, so it's a luxury cabin experience, but we're designing it from the start with the research and education and other commercial applications embedded in the design. When we went through systems requirements review earlier this year, that was a significant part of the requirements have to do with everything from payload mounting to proper kinds of windows for viewing, attitude control, communications, command and telemetry, all that. This is the team. Jane Pointer is our CEO, and you may know that this company, Worldview, was spawned out of another company that Jane is the CEO of, Paragon Space Development System. Tabor McCallum, Jane's husband, serves as our Chief Technical Officer. I know many of you know Tabor and Jane. I'm the Chief Scientist, and just a couple of months ago, we announced that Mark Kelly, former shuttle commander, has become our Director of Flight Crew Operations. Shortly, we'll be announcing another name to our key team, and you'll be seeing a little news about that next month. Some of our partners in building the Worldview system include Paragon, who's responsible for capsule development and other aspects of the human rating of the system, Priestman Good, an award-winning cabin designer, and United Parachute Technologies, who's involved in the shuttle program. I want to tell you a little bit about Worldview by showing you the first of 2 short videos. I think they have to initiate it up in the back. I'll let you guys do that. Well, if you're anything like me, you can't wait till the system's operational. Let's see if we can get out of the video and back to the slide deck. There we are. So let me talk a little bit to begin with about the tourism aspect of the business. This is a new option for people that want to see the Earth from space altitudes. But instead of only having a matter of minutes, like a suborbital vehicle, we loiter for hours on the edge of space, and people can really take the experience in and watch the clouds go by, see the lighting change, spend a morning or an afternoon on the edge of space, and really know what it's like to spend the same amount of time, for example, that astronauts like John Glydd did on their early flights. We think the tickets are at a very competitive price point. As I said, we fly up to 6 flyers with a crew of 2. That means you can take your family, your friends, fly with colleagues. And for researchers, it means that you can deploy some pretty complex research experiments, having multiple people. If you want to do medical experiments, you can take multiple test subjects along the way. And there are no extreme environments for a flight like this. No high Gs to train for, no real medicals required, no real training required. That's one of our objectives. You shouldn't have to have any more training, we hope, than you do to fly on a commercial airplane flight. No special gear to wear either. That's a pretty good value proposition for the tourists, because we know that a lot of people are concerned about those Gs. A lot of people question whether a few minutes in space is enough for the kind of money that they're spending, and we think that this is going to be very competitive. Now, in addition, there's a very large interest that we're seeing in something called stratolites, like satellites, but that fly in the high stratosphere, and that can do anything from communications to remote sensing at a much lower price, because we don't have to deploy them to space. We see a very large market for this developing over the 20-teens and 2020s with a whole variety of applications, which I alluded to: communications, remote sensing, as I said before, research and education that I will speak to shortly, first response, surveillance, weather, and a variety of other applications. And the interesting thing from our perspective, starting this off as a company with an interest only in the research and education and the tourist markets, are how often we find other businesses and government agencies knocking on our door to look at how we could deploy their systems to the high stratosphere in small and sometimes in very large numbers to fly fleets of systems for everything from airborne internet for countries that are underserved to technology testing to remote sensing. In the research and education world, we think we offer something really special. Because we're human-tended or automatic, we can fly the payloads or the people. We can fly mixed mode as well. We can let researchers operate the same way they do in their university or industrial labs, removing the need for automation that we have to put at great expense on satellites and rockets. And we can offer, at these prices, a space option for any nation on Earth. Any nation on Earth can afford this kind of space flight on a frequent and routine basis. By comparison to an orbital flight, a seat aboard worldview is about 1/300th the cost. And there are numerous research and education applications. And the reason for that are some of these advantages that we think that we offer over other systems. For example, while all of us love zero-G as an experience, if you've ever tried to get work done on a zero-G flight, you know that it can be really difficult. It can really make getting the job done a lot tougher. We don't have zero-G on our flights. That makes getting the job done for a researcher and educator a lot simpler. Another example is that at lower speed, we're able to do many kinds of atmospheric sensing and meteoritic sampling, et cetera, that are very difficult if you're flying supersonically, and you have to put the samples through that shock. We have increased range over the kind of suborbital systems that are currently being fielded. We can actually fly point to point across a state, across a continent, across an ocean. Lower Gs, obviously, because we don't have to put our people and our payloads through a rocket ride. These are all advantages for research and education. That's not to say that the suborbital vehicles don't have their own advantages. They do. But this is a very complementary system with many advantages that we think for research and education is going to light the world on fire for near space activities. Some of the other advantages I've spoken to earlier, lower cost, longer duration, and the fact that we can human tend the payloads or the educational applications and therefore make them much more effective at much lower cost for the payload providers. We put together a advisory team for research. You may recognize some of these names: Bobby Braun, Stan Solomon, Craig DeForest, Mike Summers, Peter Jeniskins, Dave Grinspoon, Faith Vilas, and Greg Guzik, in a variety of different fields, each advising us on everything from atmospheric science to technology testing to astronomy and astrophysics. And we're finding applications in all of those areas. So let me give you a little look ahead at what we're doing and where we're going. We've already begun our flight test program. I'll show you a little bit more about that in just a moment, with our first vehicle called Tycho. The Tycho 800 system just flew for the first time last month, and it's shortly going to be available for commercial flight. We're going to a much larger system that will also be fielded simultaneously to fly much larger payloads called Tycho 8000. Then we're going to develop our own online balloon manufacturing capability because, frankly, we're going to dominate the world market for balloons, and we want to control that supply chain. Then we'll go to full-scale unmanned flight tests and then human tests of the vehicle before we fly any tourists, and we hope to be at that point late in 2016, just under 2.5 years from now. Our first product, Tycho 800, is already available. As I said, it's had its first test flight and it was fully successful, and we'll be fielding a larger system early next year. These are images from that test flight last month. You can see mission control, upper center. You can see the flight path, upper right, the launch, upper left, and a view from the vehicle at altitude. I want to show you a little bit more about that test flight. This is a video that Tabor and Jane just put together, and if you all can start it in the back, it runs about 1.5 minutes. Enjoy.
2011. Began working on Worldview in 2011, and we tested components of the system and subsystems at smaller scale leading up till now. But this was the first time that we'd sewn all of the different parts of a full flight together.
Worldview is about giving people that incredible perspective of seeing the Earth that we live on as a globe in the blackness of space.
We have experts in the parafoil system, we have experts in the flight and balloon control system. The big advantage of a balloon is that it has so little energy.
Imagine getting into a capsule pre-dawn, start gently rising up.
Floating to the top of the atmosphere. We cruise for about 1.5 hours at the flight. Got great views of our Earth in the blackness of space. Then we start to descend to a lower altitude where we then transition to essentially a big wing and fly down to a location that we want to be. The test flight was phenomenally successful. We got data in every part of the flight. We smashed records for altitude flight with a parafoil, came down to a perfect landing. It was recovered by the team. We were just thrilled with the results and the success of this test flight.
All that imagery is from the test flight itself. Those were real images taken at altitude, 120,000 feet. Now I want to make an announcement to do with our research and education program. As a part of our test flight for the Tycho system and later for the Worldview experience, the human-rated capsule, we also want to test our ability to do research and education. So we've now selected our first 3 payloads for flight. We've signed agreements with 3 different entities and 3 different principal investigators to be a part of our test flight program, to fly an ozone experiment, a radiation monitor, and a meteoritics experiment on flights beginning this year so that we can gain experience about our payload integration processes, our flight process, get feedback from real live principal investigators. Peter Jeniskins of the SETI Institute here in the Bay Area is PI of the meteoritics pathfinder that we'll be flying. SETI, if you don't know it, is an organization called the Search for Extraterrestrial Intelligence, but it's much broader than that, doing many kinds of space science research. It's a nonprofit. RMAS, which is our stratospheric radiation monitor, provided by Dr. Kent Tabiska of Space Environment Technologies down in Los Angeles, a for-profit company that's been flying payloads like this on high-altitude platforms and airplanes for years is going to now be able to do radiation monitoring for long duration flights that they can't get with rockets at altitudes above what they can get with airplanes. And then J.D. Mukherjee, of the director of the Florida Space Grant Consortium at the University of Central Florida, is the PI for our ozone education experiment, flying a student experiment to do ozone monitoring high in the stratosphere. That's going to give us our first taste of doing projects with students and for educational purposes. We're very excited about all three of these. We're looking forward to flying them beginning later this year, and we think that it demonstrates not only that we're serious about the research and education market, but also it signals that our doors are open, we're ready for customers to fly payloads, and that you won't have to be first, you won't have to be the guinea pig, because these three experiments, flying at no cost to the experimenters, in exchange for their providing the experiment and helping us get some experience under our belt with research and education, will be the pathfinders for you. So we're rising. We're excited about it. We've seen huge interest in what we're doing in the media. We see crazy numbers of web impressions on the stories about the worldview. We've completed our seed round very successfully. We've, as I said earlier, completed the system requirements review. We have the subscale vehicle now in testing, and you've seen imagery from that flight, both the launch and actually up on altitude. We've just begun the Research and Education Pathfinder program that I just mentioned, and we're closing our A round. So the future is bright. A company like the balloons is rising. Thank you for your time, and I'll take any questions. Thank you.
I'm sure you're aware of the concepts JP Aerospace has put together for getting into orbit. I was wondering if there's any connection between you guys, or if there's any way this fits in.
Maybe you could summarize that a little bit for the audience, and then I can speak to it.
Well, if my memory of it, the idea is you have one balloon that takes you 120,000 feet. Then you establish a base at 120,000 feet where you build another balloon which has aerodynamic shape and rides on the very tenuous atmosphere up to orbital velocities. And the real kicker, the hardest part, is the engines to do that, which are TBD.
Yeah, we're aware of those concepts, but we're not currently partnered in anything like that. I'd be happy to talk about it, though, if you're interested. Other questions?
With the constellation arrangement where you for communications, what's the proposal for being able to keep the balloons where you want them, given the winds and the dynamics of the atmosphere?
Have you ever flown in a balloon?
A hot air balloon, yes.
Yeah, there you go. So the
Didn't
flight
necessarily go where I wanted it to.
Not necessarily, but by flying a large number of balloons, you can, over a statistical ensemble, ensure that you've got coverage over a large area. And we can vary our flight path by varying our altitude and finding the winds that are going the direction that we want. And with modern technology, computing and communication between the vehicles, you can coordinate that ensemble of vehicles in ways that were never possible in the past.
Okay, so how many more balloons would you need than satellites to do the same job for coverage?
Sure. Instead of flying hundreds of satellites, you fly thousands of balloons.
Right.
Hi, Eric Dahlstrom. One of your images shows a flight over the Terminator. Are you talking about, are you thinking of night flights or dawn flights?
So initially we're going to be launching when the winds are calm with our early systems, typically launching at dawn and flying in the morning and coming back before conditions get a little more challenging. But our ambition is to be able to fly long duration systems like communication systems that'll fly for weeks and months at a time. So 24 hours a day, 7 days a week.
I'm just wondering, can you speak to the experience, a couple questions, the visual range from 20 miles, how far can you see? Looking at the sky, looking up, how does that compare to, say, going to the top of Mauna Kea or something like that? And then are you selling tickets yet? Or are you taking reservations?
Sure. Well, first let me say we are selling tickets. The first few flights are already sold out, but we have a couple of different programs available, and you can jump right in anytime you'd like. In fact, I can talk to you just after the
I'm on the
talk
sales
this
side,
morning.
so I'm interested in that. So.
Great, super. Okay, and your other question?
From 20 miles, what's the visual range?
Well, it's spectacular. As you can see, you can already see the curvature of the Earth. You can see literally hundreds and hundreds of miles.
Okay.
And through the clarity of the vacuum, almost all the way down. In fact, when you look down, you're only looking through a few miles of really sensible atmosphere. So you can see how sharp those images were. And from our test flight site in New Mexico and our first operational base in Page, Arizona, you'll be able to see everything from the west coast of the United States all the way across the Midwest and north into the northern Rockies, south down into Mexico and Baja.
Got it.
Pretty impressive.
Okay. And then in terms of the blackness of space, I mean, is that...
Flying at altitudes of 100,000 feet, to your eye, is indistinguishable how dark the sky is above you.
Got it. Thank you.
Absolutely. Okay, I think I'm getting the word. It's 29 minutes, so we'll call it 30. Thank you very much.